Hello everybody, today we are going to look at the technical drawing of different types of external walls. Firstly, let's remember the categorization of the external walls according to the structure of them. Structure, load bearing part of external walls consist of four different types. The first type is masonry. Okay, alternatively brick or block work. The second type is frame. These two are the most popular types. Frame can be produced from wood studs or light-weight steel profiles. Okay, the third one is casting, and the fourth one is panel. They are rather rare and not the subject of this term. This term we are going to focus on masonry and frame structured external walls. Firstly, let's remember our building and let's try to make you understand what wall of the building we are going to work on. This was our building, you know, this is the main entrance. Here is the stair of the building. We have got a bedroom here, a bathroom here, the kitchen counter is there, okay, and the veranda is here. We get out to the veranda from a door that we have here. We have got a window there, another window here and there, I guess. Okay, so let's draw the window of this wall like it is. Okay, so let's say that these are showing the thickness of the walls, and let's work on this wall in our drawing. Okay, but before talking more about that, let's remember the columns of the building. We have got a column here, another column here, one more long column there, okay, one more column here, here, and the last column is here. Okay, the reason why I draw those columns is because we are going to show those columns in our drawing as well. Okay, so what will we do? What are we going to do? We are going to, okay, draw a partial elevation of this part of the building. Okay, a partial elevation. We are going to look from here. This is the schematic showing of an eye. With that eye, we look to that wall. Let's take a new sheet of paper, okay, and let's start drawing it in a larger scale. Okay, let's leave this aside. Okay, what do we have? Let's put this paper here. So you see that we have a column there. Okay, firstly, let's start drawing the plan. Okay, yes, let's start drawing the plan firstly. Okay, what do we have? We have got our column here. Let's draw that column. Okay, here's our column. Okay, let's draw the floor. The floor is going like that, and we have another column right here, like this. Okay, so you know, dashed and dotted line shows something which has been cut by the section plane. So here we cut the floor like that. Okay, and the veranda is here as well. So let's draw here a dashed and dotted line to show that building continues that way. And let's draw the border of the building like that. Okay, and yes, let's put a dashed and dotted line here also. Okay, so firstly, masonry wall. We are working on a masonry wall. What do we have? In masonry walls, we have got rectangular prisms like this. Remember, we put these rectangular prisms next to each other, and we tie them to each other with mortar, and we form our wall. Okay, and what about the size of these rectangular prisms? It's something around 40, 20, and 20, let's say. Okay, we are talking about a rectangular prism of 40 centimeters in length, 20 centimeters in depth, and 20 in height. Okay, and these rectangular prisms may be produced from clay soil, okay, which we will call as brick, or clay soil, or they can be produced from aerated concrete, gas concrete, okay, which we are going to call block. But the size at this stage is not very important. Let's say the average approximate size of any of these blocks is 40 length, 20 height, and 20 depth. Okay, what was the width of our column? You remember that from the previous lectures. Okay, the column has 40 centimeters of depth and 100 centimeters of length. You remember it is a column of 40 by 100. Okay, so and we do not need to draw it scaled, but we need to draw it proportional. Okay, so if from this corner to that corner it's 40 centimeters, our wall will be smaller than that. So what am I going to do? I'm going to draw a parallel line to here. Okay, and that parallel line, these two parallel lines, okay, initially the first parallel line was representing the edge of the floor. Now at the edge of the floor we start putting these blocks, these bricks, okay, and this line overcomes onto the edge of the floor. That's why now this line is representing this face of my rectangular prism. Okay, and what am I going to do? I'm going to start drawing blocks like this. When I come to the middle part of the wall, I'm going to stop putting rectangular prisms because I want to leave a window opening there. Okay, so I start putting first, second, third, fourth, I start putting blocks like that. When I come to this place, I stop putting blocks and I leave a gap. I leave an opening. That's the external wall opening. And when the external wall opening finishes, I continue putting more rectangular prisms. Okay? If a small area is left, okay, what are we going to do? We are going to cut these bricks or blocks and we are going to put a smaller one there. Okay, so in order to make you understand it better, now I'm going to pass over my drawing more harder. Okay, and these are my bricks. I stop putting those bricks there and I leave a window opening and I continue putting more rectangular prisms like that. Okay, so I put many of them and I left a window opening there. By the way, you may ask me what will be the height of the parapet wall. You know, now here we see the parapet wall from top. Okay, in order to see that, we firstly need to understand from what level our section plane is passing from. This is ground line. Okay, you know this is my ground floor line. Okay, and this is my veranda. Okay, so this line I don't see it. Okay, it's behind the external wall of the building. This is the floor level, this is the ground floor level. Okay, and here is I carry lines. Okay, here is my window like this. Okay, and here is the corner of the building and there will be the main entrance door here like that. Okay, and here is the stair of the building like that. Okay, we have talked about that. Okay, so this plan of the external wall is passing from here. and we are looking down. Okay, but we are not drawing the entire drawing, you know, we are just drawing this part in detail, because this drawing is for understanding the external wall of the building. Okay, that's why we put bricks. We stop when we come to the window opening part, okay, external wall opening part. We didn't put any bricks at this level, okay, but we of course have bricks here. Okay, so if we are passing the section plane from here, we need to draw the bricks or blocks at that point as well, okay, because bricks, we do not put any bricks, only on the external wall opening part. When the external wall opening finishes, we continue putting again rectangular prisms, brick or block, okay, and all of them right here, there, okay. What do we have? We have got mortar for sticking them to each other, for tying the bricks, tying the rectangular bricks, the rectangular prisms to each other. Okay, so it will be named as a mortar if it is used as a glue. It's a mixture of sand, cement and water. Same mixture, almost the same mixture. The amount of water is maybe a little bit different, okay? If we use or produce the same material and apply it on the surface of my brickwork wall, here on these surfaces, if we apply it, okay, then we are not going to call it as a mortar, we are going to call it as a plaster. What plaster? We are going to call it as a cement plaster. Cement, it's a cementitious product used to straighten and flatten the surface of masonry walls. Okay, what is the thickness? It is around 2 centimeters in thickness. So what will I do? I am going to apply plaster here, and I'm going to stop at this point, and I'm going to apply plaster there as well. Okay, but would you like to see a corner right at this point? Or when you look at the buildings, can you, from the outside of the building, can you recognize the columns, or are they all hidden behind the paint? Okay, we usually do not see the columns. We cannot separate the columns and the wall parts of the buildings, because they are entirely covered together with our cement plaster. Okay, what we do, we are going to turn the plaster to this side as well, like that. And we will do the same thing for the inner side of my masonry wall as well, like that. Okay, we are going to surround it all the way. And we have talked about performances. You remember performance? The behavior of an object under environmental usage conditions. So what we need to do, we need to better the thermal performance, sound related performance, mainly these two performances of our external walls, and we are going to do that by using a thermal insulation material. Thermal insulation. Okay, the thermal insulation material that we are going to put on our external wall is also going to better the sound related performance of the building. We are not going to add an extra insulation material, especially in masonry walls, because sound waves, okay, sound is a wave, you know, sound wave, okay, cannot vibrate very massive and heavy objects. Okay, so sound waves cannot vibrate, you know, sound wave, it's an airborne sound, airborne sound. Okay, the air atoms is vibrated by a sound source like the voice cords of mankind, and those vibrated atoms of the wave of the air is going to move like a wave, and when they hit to our wall, okay, they will try to vibrate the atoms of the masonry wall as well. But masonry wall is heavy because they are produced from solid bricks or solid blocks, which are not very light, which are not feather light. Okay, so it will need more energy for vibrating them. They will need more energy to be vibrated, and usually sound waves cannot vibrate them so easily. That's why, again, in a masonry wall, we do not usually need to take a precaution against airborne sound. Okay, but at this point, what will I do? I'm going to erase these two lines. Okay, because you know that those are representing what? That's parapet wall. And what will we do? We are going to apply plaster to our parapet wall as well. Okay, that's why I'm going to redraw these lines faintly like this. Okay, I have made them more thick now because they are also plastered. And we now will add thermal insulation material. And what will we do? We are going to apply the thermal insulation material from the outside of the building. Directly we are going to glue them. Okay, let's draw them like this, and let's put a dashed and dot line here as well. Okay, and I'm going to draw a zigzag like this in order to represent the thermal insulation material. Okay, and I'm going to put the thermal insulation material here and there also, and I'm going to draw a zigzag line. Like this. Okay, and I'm going to erase this line again because the outside of the parapet wall is also thermally insulated. That's why I now need to increase this thickness more. Okay, it's more thick now. And would you like to see a thermal insulation material on the outside of the building? Outside of a wall? The answer is of course a no, because thermal insulation material, is it a finishing material? No, that's an insulation. So what we need to do, we need to finish it with a finishing material. And what's the finishing material? The finishing material is also a thin layer of plaster and then paint. Okay, we apply plaster and paint to it also. Okay, now what I will do is I'm going to draw a line to here. And what's the outest line? Outest line is special thin plaster plus paint. Paint is usually very thin, not usually, always, it's very thin. That's why we do not write it as an extra layer. We just put a plus to the plaster usually and add the word paint. Behind the paint and special thin layer plaster, what do we have? We have got thermal insulation. Behind the thermal insulation, we have got cement plaster. Behind cement plaster, we have got brick core. And behind brick core, we have got again cement plaster plus paint. Okay, and now we have supported our drawing with written information. Let's write the thicknesses of them. Let's give some information about the dimensions. The thickness of the special thin layer plaster is around half a centimeter. Okay, paint is just 10 microns. So what we will do, we are not going to give any thickness for paint. Okay, together special thin layer plaster plus paint is around half a centimeter. The thickness of thermal insulation will change according to the climatic region of the building. For Istanbul conditions, around 5 centimeters of thermal insulation material will be alright. The normal cement plaster that we apply directly on top of the brickwork core will be around 2 centimeters. The brick core is 20 centimeters, and the inner layer of cement plaster plus paint is also another 2 centimeters. Okay. Now we are going to look to our building from this side. Okay, let's take another sheet of paper. Let's put it here. Okay, I didn't use the sheets very effectively. Just a second. Oh, let's do it this way. It will be much better. Okay, now let's carry lines. The first line belongs to this corner point of the building. The second line belongs to this other corner point. Okay, so now what I will do, I'm not going to draw the thermal insulation continuously because I want to see what is there inside. So what will I do? I'm going to draw the column. Okay, and this is the opening. Like this. And this is the other column. Okay, let's draw the ground line. Here is the ground line. Okay, let's draw the ground floor line. Okay, very faintly. Here is the ground floor line. Okay, and let's draw the top level of the building. Okay. And this is my window. Let's draw the window opening firstly, like this. Okay. And that's all. What I will do, I am going to pass over the columns firstly. Column. Okay, continues until to the ground. Here is the veranda. I'm not very interested about the veranda. Okay, that's not, I'm trying to draw it very well. Okay, this is the column. Okay, that's the other edge of the column. That's the finishing line of the column. Okay, columns start from the top level of the building and continues until the foundation. Okay, now the foundation is buried under the ground. But in order to make you understand, I will draw them dashed like this. And this column here, let's draw that column as well. And this is how we see it in the background. This is a what type of foundation? This is a reinforced concrete strip foundation. Okay, and on the ground level, what do I have? I have got a layer of concrete here, okay, which we call lean concrete. That's a floor on ground type of floor. Okay, floor on ground type of floors have gravel underneath them, and below the gravel, what do I have? I have got my compacted soil. And all these layers will be covered, or if, let me ask this way, if this is the ground level and we generate that floor as a floor on ground, from the side of the building, is it possible to see any compacted soil, gravel and lean concrete? Can soil stay vertically? No, it cannot. Okay, what do I try to mean? Let's explain it with a section passing from here. Okay, so here is my floor on ground. Okay, I'm trying to keep floor on ground like that. This is the column in the background, like this. This is this column. I see it inside. Okay, so now I'm drawing this section. Let's name it as B section. Okay, and this is my ground level. Okay, and what did we do? We have placed compacted soil here and gravel there, and we have covered it with lean concrete. Okay, so can this soil now stay perpendicularly like that? Of course can't. So what will we do? In order to keep soil vertically, we need to support it with a retaining wall. That's why we are going to construct here a retaining wall. It doesn't need to be a wall. It needs to enter slightly into soil, maybe 5 centimeters. Okay, so this height was how much? Do you remember? It was 72 centimeters. Okay, so let's add an extra of 8 centimeters here, and let's make the height of that wall around 80 centimeters. And let's not make it as a wall. Instead, let's make it as a beam, because the foundation, the column continues like that. Okay, and here is the strip foundation. Okay, we don't need to continue it until the strip foundation, because we do not have a basement floor. We are just going to, we don't want to spend more money. Okay, we are just going to construct it until 5 centimeters. Here in this example we made it 8 into the soil. Okay, we reduce the extra need of spending more money for lengthening it to the foundation. That's why we are going to call it as a plinth wall, or alternatively we can call it as a basement beam. So we call it as a plinth wall or a basement beam, and its function is to prevent the floor on ground to try to fall down to the ground level. Okay, that's why here we do not see any of those layers. All we see here is what? Okay, I'm going to hedge it like this. So that thing that we see there will be named as a plinth wall or basement beam. Okay, and we will start constructing our external wall on top of our plinth wall and on top of our floor on ground. Okay, what will I do? I'm going to draw these type of lines. Okay, showing the lines of my rows of the masonry wall, and I'm going to start drawing vertical lines for representing the vertical joints in between my rectangular prisms. Okay, be careful. Masonry walls are like playing with Lego blocks. Okay, and in order to interlock these two rectangular prisms to each other, the upper rectangular prism need to come right in the joint, right over the joint of the lower two blocks. Okay, similarly, this rectangular prism is tying these two bricks to each other. Okay, what we need to do, we should avoid making vertical strips, generating continuous vertical strips. This is my external wall opening. Okay, on the sides of my external wall opening, I need to continue putting my lines. like that. Okay, so is this an opening? Yes. Do we have a span from here to here? A clear distance? Yes. So in order to pass that span right here, what should I put? I should put a beam, a special beam, which is placed to pass the external wall opening span. Okay, and the name of that beam is what? That is a lintel. Lintels may be produced from reinforced concrete, steel, even wood. But in reinforced concrete structured buildings, they are usually reinforced concrete as well. On the sides of my lintel, I continue putting more brick or blocks over the lintel. I continue putting more bricks. Okay, and right here I'm going to put more bricks like this. Okay, of course we forget something. We forget drawing the floor, the upper level span passing floor. What will I do? I'm going to draw it like it is a hollow slab floor. Okay, just a second. The battery is about to be drained. Okay, let's continue. And here is my hollow slab floor. It continues this way, but I'm not interested on drawing these parts. Okay, and I will hatch the reinforced concrete part of it in order to make you understand it. Okay, in fact we will not be able to see the inside of the reinforced concrete beam, the reinforced concrete floor, because all this place will be the side view of my floor's beam. Okay, I draw like we see the inside of it because I want to show that there's that floor there. Okay, so what you need to do, you need to draw in fact the external wall opening like that, and all other parts, all these parts are what? Are reinforced concrete. Okay, like that. And then what will we do? We are going to apply the plaster. Let's take some colored pencil from here. Okay, with red. Okay, I'm going to represent the exterior plaster plus thin layer plaster plus paint. Okay, with purple I'm going to represent the thermal insulation, and with orange I'm going to represent the cement plaster. First cement plaster. Okay, what will I do? I'm not going to draw cement plaster entirely. Okay, instead I'm going to hatch it like this. All these areas will be covered with plaster. Okay, and then of course this area is covered with plaster as well, but in order to make you see, I didn't hedge them. Okay, and then over the plaster we are going to cover the plaster with thermal insulation. Okay, let's draw thermal insulation like this. This entire thing is thermal insulation, and over the thermal insulation we are going to apply thin layer plaster. Okay, so now let's write. Okay, this is the brickwork core. Okay, so orange is the cement plaster, purple layer represents the thermal insulation, and the red place represents thin plaster plus paint. Okay, great. Let's very quickly draw and finish our section as well. Okay, and this is my wall, this is the window opening until here. Here is my lintel, and here's the brick. Okay, going over it. On top of the brick, let's draw with orange. We apply thin layer plaster. We apply normal plaster, and then we cover it with